In 1977, humanity launched 2 spacecraft into the darkness of space, and in many ways, they never truly came back. Instead, they continued their journey beyond the worlds we thought we understood, past rings we believed were simple, and beyond moons we assumed were cold, silent, and lifeless. With every image they transmitted to Earth, the solar system became stranger, more dynamic, and far more alive than anyone had imagined. Voyager 1 and Voyager 2 were much more than robotic spacecraft. They became humanity's eyes in the outer solar system, revealing giant storms, erupting moons, hidden rings, shattered icy worlds, and even the fragile beauty of Earth itself. Their greatest achievement was not simply photographing distant planets. It was transforming our understanding of them. Jupiter ceased to be just a striped sphere and became a world of violent atmospheric motion. Saturn's graceful rings were revealed as incredibly complex structures. Uranus emerged as a mysterious planet tipped on its side, while Neptune became a world of enormous storms at the edge of sunlight. Along the way, the Voyagers also turned their cameras back toward home, showing humanity its own planet from an entirely new perspective. The Voyager story began with a rare cosmic alignment that occurs only about once every 176 years. During the late 1970s, Jupiter, Saturn, Uranus, and Neptune lined up in such a way that a single mission could visit all 4 giant planets by using gravity assists, allowing each planet's gravity to accelerate the spacecraft toward the next destination. NASA recognized this extraordinary opportunity and moved quickly to take advantage of it. Voyager 2 launched first on August 20, 1977, followed by Voyager 1 on September 5, 1977. Although Voyager 1 launched later, it followed a faster trajectory that eventually allowed it to overtake its twin. Together, the spacecraft carried humanity's curiosity into regions of the solar system that had never before been explored in detail. Even during the earliest days of the mission, Voyager offered a remarkable perspective. Shortly after launch, Voyager 1 looked back toward Earth and captured an image of Earth and the Moon from millions of kilometers away. It was a quiet reminder that this extraordinary journey began from a single fragile blue world slowly fading into the darkness of space. Looking back today, that image feels almost prophetic. Before Voyager, the outer solar system remained largely a collection of educated guesses. Astronomers had telescopes, theoretical models, and expectations, but they lacked close-up observations. No one truly knew how the atmospheres of the giant planets behaved, how their moons evolved, or what hidden activity might exist beneath their icy surfaces. Voyager was about to change all of that. When Voyager 1 reached Jupiter in March 1979, followed a few months later by Voyager 2, the solar system suddenly became a much more fascinating place. Jupiter had been observed for centuries through telescopes, but never with such extraordinary detail. The giant planet transformed from a distant disk into a living atmosphere filled with enormous turbulence, swirling clouds, violent jet streams, and storms nested within even larger storms. The famous Great Red Spot was revealed as a massive rotating storm system unlike anything found on Earth. Yet even that iconic feature proved to be only part of Jupiter's story. The surrounding atmosphere displayed an astonishing level of motion and instability, making the planet appear less like a calm world and more like a gigantic engine powered by constantly shifting weather systems. Perhaps Voyager's greatest surprise, however, was not Jupiter itself but its moon Io. Before the mission, scientists believed Io would resemble Earth's moon, an ancient, heavily cratered, geologically inactive world. Instead, Voyager discovered something completely unexpected: active volcanoes. For the first time in history, humanity observed volcanic eruptions on another world. Towering plumes blasted volcanic material hundreds of kilometers into space. Vast lava lakes covered portions of the surface, and continuous geological activity reshaped the moon in real time. The discovery forced planetary scientists to completely rethink their understanding of how moons evolve and remain active. Another of Jupiter's moons, Europa, proved equally intriguing. Voyager revealed a surface covered by long, intersecting fractures crossing a shell of bright ice. Even then, scientists suspected that these mysterious cracks might conceal a global ocean beneath the frozen crust. Within a single planetary system, Voyager had revealed both the most volcanically active body in the solar system and an icy moon that could potentially harbor liquid water beneath its surface. That was the moment when the outer solar system stopped appearing cold, silent, and dead. After Jupiter came Saturn, where beauty gave way to even greater complexity. From Earth, Saturn had always appeared elegant and peaceful, defined by its magnificent rings. But Voyager's close-up observations completely transformed that familiar image. Rather than a few broad, smooth rings, Voyager revealed hundreds of delicate ringlets woven together into an intricate system filled with narrow gaps, twisted structures, subtle waves, and countless fine details that astronomers had never anticipated. The spacecraft also discovered previously unknown rings, along with tiny shepherd moons whose gravity helped maintain the narrow ring structures. Even more puzzling were mysterious spoke-like features stretching across Saturn's B ring. These dark radial patterns appeared and disappeared in ways that challenged existing theories about the behavior of ring particles and electromagnetic forces. In only a short time, Saturn's rings evolved from one of the solar system's most recognizable sights into one of its greatest scientific mysteries. Saturn's moons proved equally remarkable. Titan emerged as a world enveloped in a thick atmosphere rich in nitrogen, making it unlike any other moon known at the time. Its dense atmosphere immediately established Titan as one of the most compelling destinations in the solar system and a prime target for future exploration. Meanwhile, Enceladus displayed hints of geological activity that would later be confirmed by subsequent missions.